Okay, Assalamu alaikum wa rahmatullahi wa barakatuh, and a very good evening to all of you. Let's start today's class. Okay, picture work done, a few end of chapter question tackled, a notebook ready for the next chapter. I think no one has prepared the questions and answers what we have read here, so I would request all of the group members to prepare all these questions to answer of this question, please. Okay, let's do the next chapter. Chapter 4. Brain links and fun with the space aliens. Santiago was 11 years old and in trouble, big trouble. This time he landed in jail. He had it coming. Santiago argued endlessly with his father and fought with his teachers. He was kicked out of school time after time, but this time he had blown a hole in a neighbor's gate with a homemade cannon. He hated school. He didn't have a good memory, which made it hard for him to learn in exactly the way teachers wanted him to learn. He especially hated maths and didn't see the point. He liked to draw, but his father thought drawing was useless. Santiago was going nowhere fast, but guess what? Santiago eventually won a Nobel Prize. That's like an Olympic gold medal for a science. He became the father of modern neuroscience. Bad boy Santiago Ramon Y. Cajal became one of the greatest scientists of all time. He used art skills and math skills. We are going to tell you how it happened, but first, let's learn a little about the brain. This will allow you to understand one of Santiago's breakthrough discoveries. It will also help you understand how we learn. Friendly space alien, how neurons talk. Let's start with a few simple ideas about the brain. Your brain has a lot of neurons in it, billions, roughly the same number as the number of stars in the Milky Way galaxy. Neurons are the building blocks of your brain. They are small. They are really small. 10 neurons are only as wide as human hair, but they can be longer than your arm. To understand neurons, you can think of tiny aliens from outer space. Yes, aliens. Can you see the eye of the neuron alien below? Here? Here. Yes. Technically, the eye is called the nucleus. There is a nucleus in every cell in our body. The neuron alien's single arm stretches above, almost like a hat. The neuron alien's 3 legs are underneath. Okay, so these are 3 legs, right? A neuron alien, our metaphor for a real neuron. So this is just a metaphor, isti'ara. Neuron aliens are bizarre creatures. They have only 1 eye, 1 arm, and 3 legs. In real life, neurons can have more than 3 legs. Lots more. They come in many shapes and sizes, with more variety than all the other types of cells in your body. Below is a drawing that much closer to look of a real neuron. Down below are the neuron's legs. They are called dendrites. Up above is the neuron's arm. It is called an axon. See here. This is axon, this part, and dendritic spines. These are dendritic spines, and these are dendrites, right? So this is the neuron having its usual bad hair sort of day. Look at those knobby spine of the dendrites legs of the neuron. Those are called dendrites spines. They are like toes scattered all over the space alien's legs. Remember, this is an alien. It doesn't look like we do. Dendrites spine may be tiny, but they are important. You will see them again in some unexpected place in this book. Here is a key point. Neurons send signals to other neurons. Like here. What is neuron? It's easiest to understand this by returning from a moment to our space aliens. When one neuron alien wants to talk to the next alien, it reaches its arm out and gives the tiniest of shock on the toe of the next alien. See? So this is the toe of next alien and this is the arm. And it is giving shock to the leg of this neuron. When one neuron aliens, next alien. These particular aliens show friendship by giving tiny shocks to one another. Weird, I know. It's similar for real neurons. A neuron ripples a signal along its axon to cause a shock, in a dendritic spine of the next neuron. It's like the tiny shock you feel with the static electricity on a dry day. One neuron sends a shock across a tiny narrow gap to another neurons. This gap is called a synapse. It's pronounced synapse in the United States and synapse in England. There, you have just understood the process of how a neuron passes along a signal. Okay, maybe it's more complicated than that. There is some chemistry involved, but you now understand the basics. Now, that is synapses. Synapse. Okay. Two neurons connect together across a synapse. You can also see a close-up view of synapse. The spark from the synapse creates an electrical signal that can flow through the neurons. If the signal reaches the end of the axon, it can cause a spark in the next neuron, and the next, and the next. These flowing signals are your thoughts. They are like the trials on your mental pinball table. Okay, here. So the sparking, this shock is sparking here. On the left is a close-up of a small synapse. Synapse. See the little spark. On the right is a bigger synapse that has grown because of practice. See how much bigger the spark is. Here this is small, and here this is bigger than that. The arrow in the picture below show how a signal could flow through the synapse and the neurons. Right? See here. So it is giving here, it is giving here, it is giving shock to here, and this then it is giving shock to here, like that. That is, we can start from here, then it is giving shock to here, it is giving shock there, that. For example, signal flow across neurons. These create your thoughts. Let's return again to our friend the neuron aliens. The more often a neuron alien shocks the next neuron alien, so that it passes the message on to its friends, the stronger the connection between them becomes. The neuron aliens are like friends who become better friends because they talk a lot. It's like that for real neurons too. Researchers often use the phrase neurons that fire together, wire together. You can think of the wiring together as creating a set of brain links. Learning something new means creating new or stronger links in your brain, a new set of brain links. Can you see here? Now there are three links are involved. These are links. So this is linking. This neuron is linking to this neuron by the axon and by the by the leg, by the arm. Okay, here. So these are your linking thoughts. A weak set of links forms when you begin to learn something. Okay, when you first learn something new, the brain links are weak. There are maybe only a few neurons linked together. Each neuron may have only a small dendritic spine and a small synapse. The spark between the neuron isn't very big. As you practice a new idea, more neurons join in, and the synaptic links between the neurons gets stronger. This means the sparks get bigger. More neurons, stronger synapses, the brain links get stronger too. Longer brain links can store more complex ideas. The opposite happens when neurons don't fire together. Their connection weakens, just like two friends who don't talk anymore. See here. So the connection is growing and growing and growing. Okay? So the more you practice, the stronger your set of brain links gets. Some people like to think of a set of brain links as if they were paths that a mouse runs along in a forest. The mouse is like the bouncing thought ball in the pinball machine metaphor. The more times the mouse runs along the pathway, the clearer the path becomes. The wider the path is, the easier it is to see and follow it. So then, what is the mouse metaphor for the diffuse mood? Simple. It is in the diffuse mood, the mouse, the thought, doesn't run along the path. Instead, the thought mouse jumps onto a tiny drone and flies to its new location. Okay? So it is just see here. So it's just like flying. Here. So neural paths get wider and easier to travel on the more your mental mouse runs along the path, right? Don't worry that you might accidentally use up all your neurons while you are making bigger and wider brain links. You have got billions of neurons, and your brain is growing new neurons all the time. More than that, you can make billions and billions of connections between neurons. The fact that trails in your brain can change and grow is called neuroplasticity. It's pronounced neuroplasticity. This fancy word just means that your neurons are like clay you can mold. That is, your neuron can change. This is why you can change. Got it? So the moral of the whole today's lesson is that that neuroplasticity can be changed. Right? Okay. Let us be tomorrow for today. I think that's enough. Jazakallahu khaira. Assalamu alaikum wa rahmatullahi wa barakatuh.